So in today's class we learn about how to design a gear in mathematical way, or in another way you can say we are solving problems related to gear. So first of all we have to understand the question. In question it is given that a pair of spur gear were asked to design, that is I'm making it short. We have to design a pair of spur gear, that is what do we mean by pair? Rack and pinion, for 20° full depth involute for Lewis equations. That means it will follow a Lewis equations. That means we have to follow a Lewis value. The velocity factor should be accounted in terms of dynamic loading. What is dynamic loading? The loading what we have, I mean the normal loading. The pinion gear is connected to motor, that is the pinion will be connected to motor. As we know, the pinion is the driver of gear sections, or I'll tell you about what this is. And with 5 kilowatt, that is a power transmission from pinion to gear will be 5 kilowatt. Minimum RPM is 1000 and maximum RPM is 3000. So since it is given that minimum RPM is 1000, we don't need this data at anymore. This is given only to confuse you, to retract you from the main things and you do mistakes. So you have to understand, I will be calculating the maximum things. That means we will calculate the maximum RPM, which will give us a maximum security or maximum safety of the design. The starting torque is 175% of the rated torque. That is, the starting torque is 175% of the rating. That is 175 into RT. So we'll learn about it. The speed is reduced for 1 by let us take 1 by 2, half from pinion to gear. That is, the pinion to gear, the speed gets reduced by half. So the material considered is plain carbon steel, that is having SUT 600 Newton per millimeter square. The factor of safety is taken 2. Let us design and see whether the gear is safe or not. At first, what are the given? Let us see what are the given. Given is kilowatt, that is power, that is 5 kilowatt. RPM, will neglect 1000 RPM because it's not mandatory, because it's minimum RPM. We don't need minimum, we will work with maximum for maximum security, 3000. And it is written that starting torque, ST represents starting torque, is equals to 175% of rated torque. As per the question, is 175% of the rated torque. That is, ST is equals to 175 by 100 into RT. Okay, so we know that rated torque, as well as it is given the speed. The speed is reduced to is half from pinion, that is I is equals to half. I'll tell you about this one. The material considered of the plain carbon steel is sigma UT or SUT will be 600 Newton per millimeter square. So factor of safety is equals to 2. So the thing is that we have many things. So how to start? We know that we have been provided with 5K power, RPM, everything. So for designing a gear, what we need first, we have to understand this. For that, we have to understand the gear phenomena. What are the gear phenomena? For example, we know about gear that if we consider two gear to be meshing, let us it to be G1 and it to be G2. They are meshing to each other. That is meshing, MESS. What is the criteria or the criteria to mesh of both the gears? That means there will be transfer of force, motion from gear 1 to 2. What is the criteria? The criteria is module number. That is the module of each gear, that is module of G1 and module of G2 should be same. Okay, clear till now? So what do we have to understand? That is that the module should be same. And for design criteria we have to remember one more thing, that pinion, pinion transfers motion to gear. As we have studied in the previous semesters, that pinion transfers motion to gear. That is, if a pinion rotates, the gear will also rotate. So that is, pinion will be a driver and gear will be a driven. So what I can do, I could stop over here. I could stop over here like in this way, that I have to design for pinion, and if I could successfully design for pinion, a base pinion, this will also will help me to design about gear. So so what we need to do one thing. We have to first start with assumption. There are some assumption you have to make, and as well as calculation. Assumption. Why assumption? Let us understand why the assumption is required. Let us go back to some basic formulas what we have learned in the previous class, that is m-p or m. I'll provide only m dash right now. M dash is the module or design module. M dash is the design module. Please pay attention. Remember always 10 to the power 6 by pi kilowatt into CS into FOS by Z N CV B by M SUT by 3 whole to the power 1 by 3. Now, since I told you in this point that we have to design for the pinion, because pinion is the main source of motion from which the motion will transfer to gear. So what I need to do, I need to put over here P, that is P for MP for module for P, that is pinion, teeth number for pinion, RPM for pinion, everything. Now, as per the question, the RPM is given. Like how did I got this one? The RPM is given that the pinion gear or the pinion gear will be connected to a motor of 5 kilowatt. That is, the pinion is connected to a motor which is providing a power of 5 kilowatt, as well as the RPM is 3000. So I know that NP is nothing but is equals to, or you could say NP is equals to 3000. But the most problematic thing is I don't know the ZP, so I need to assume it. So how could I assume it? Let ZP be 18. Or no, 18 will be very common thing. I will consider 19. Okay. So what is ZZ? ZZ is the teeth number. For ZP is the teeth number of teeth. It is the number of teeth. For pinion, what will be for ZZ? That is number of teeth for gear. How can I calculate it? And the simplest way to calculate it is by using a old methodology what we have studied in our previous classes. What was that? We know that ZP by ZZ is equals to NG by NP. Okay. Now, therefore, I know what is ZP is 19. I don't know what is ZG. Now, before providing the value, we have been provided with this value over here, I. So before that, we need to understand what is happening. The speed is getting reduced from pinion to gear. That means the pinion is having maximum speed and gear is getting the minimum speed. That means pinion will be 2 and gear will be 1, because it is being reduced by half from pinion to gear. Okay, I have written in this way. This will you could write in 2 by 1, because as per the question it is reduced from 1 by 2, or you may write in many way around. This is nothing you have to maintain. Now you have to just understand the question, because it's a pinion which is having maximum speed and next gear where the speed gets reduced. That's why I do what I do is I consider pinion to be 2 and ng, that is RPM for or this one gear to be 1. So for every 2 rotation of pinion there will be 1 rotation of gear, that is the speed is being reduced by half. That's why I have done this one, half. So I could write half. Therefore Zg is equals to 19 into 2 is equals to 38. So I have this data, I have assumed it. Now next I need to find out, I know this one, I know this one, that is I know the Zp, that is the number of teeth for pinion. I know Np, what is the number of, I know kilowatt, what is the kilowatt, and I missed one thing, it will be into y. Okay, this is a small place, that's why I can't write. Let me write this, equals to 60 into 10 to the power 6 by pi kilowatt into CS into FOS by ZP NP CV B by M SUT by 3 into Y 1 by 3. I have done a mistake over here. I know what is ZP, I know what is NP, what is kilowatt, that is power. I know what is factor of safety, it is given over here. I know what is SUT, it is given over here. So how to calculate the Y? How much will be the Y? So as per the Lewis table, what we have seen in our class or in the previous class, for 19 number of teeth, I'll show you, for 19 number of teeth we need to we will get a Lewis factor of 0.3. Now as I have told you, how did I got the value of 314? The value of 314 has been deduced from this table. Here you could see that 19 number of teeth, the value of y is 0.314. Similarly, for any number of teeth, that is the number of teeth is represented by z and Lewis factor is represented as y. So from the teeth number 15 to your 300, you could deduce is the or you could find the value of y from this table. This table tells you could do in this manner. For example, you need Lewis factor for 30 number of teeth. So this will be 30 Lewis factor will be 0.358. Okay. So we have, let us consider the pitch line velocity to be 5 meter per second. As we know that 5 meter per second, we have I have told you the velocity factor CV can be determined, will be determined in terms of how much velocity you take. So I will go back to your these things, how the thing is CV is calculated, CS is calculated again in the end of the video through the PPT. So CV we know, CV we know how. Since the velocity is less than 10, so we could consider CV is equals to 3 by 3 plus V, or is equals to 3 by 3 plus 5 is equals to 3 by 8. So I know what is CV. Now why did I selected this 3 by 3 plus V? Because you could see, if the pitch line velocity is considered less than 10, you have to do 3 by 3 plus V, that is CV is the velocity factor. Similarly, for your if it is more than 10 but less than 20, you have to consider CV value 6 by 6 plus B. B is nothing but the velocity what you got. Let us take an example. If you consider the pitch line velocity V to be 5, you have to take you to go over there. If you consider pitch line velocity to be 17, you have to come over there. That is CV is equal to 6 by 6 plus 17. If it is less than 10, you have to do 3 by 3 plus 5. Okay, is that clear? As per AGMA, that is EGMA, American Gear Manufacturing Association, we consider B by M ratio should to be maintained 10, 15, 20. There are so many ratios. So these are basic and the standardized ratios what to be maintained. So we are considering, for example, for SG for now, B by M ratio to be 10. Now what is B? B is the face width. I'll show, you could see that B is equals to, B is the face width. M is the module. M is the module. Module means it is the module what is predefined module. So we will neglect this one. I mean neglect in the sense we will not think about M right now. It is very necessary to for the coming calculations, since this is the standardization measure what we have to take. This is, you can't, the thing is that there may question come, sir, we are finding out module over here, even how can module can come over here. The thing is that this is the ratio. We don't know what is module over here. Wow, we don't know. We just know that as per the EGMA we have to maintain this ratio. That's why I'm directly putting B by M is equals to 10. Now B by M is equals to 10. Now what about CS? I know this, I know this, I know this. The complete down portion, the lower portion or the numerator, or sorry, denominator, I know what are the variables are there, how much is their value. But I don't know what is the numerator or this one. What is CS? Now about CS, I told you CS is nothing but is equals to service factor. Now service factor tells about how it works, what is the service factor, how much time it will work. Now there are two things you have to take in account. If it's a motor, and if it's rather than anything else than motor, I mean engine or something, or motor, or if it's not a motor. If it's not a motor, then the service factor changes. CS equals to, we know, starting torque by rated torque. ST is starting torque, RT is rated torque. Okay, CS equals to, for rather than motor, it will be maximum torque by rated torque. Now why it is so and why it is so? Why for engine it is maximum torque by rated torque? Because we could control the complete thing, complete rotations as well as the torque of a engine or a piston, or so that depends on the how much force, how much fuel are you applying, this everything. But motor provides you maximum RPM, because motor tendency, the motor was designed to provide you maximum RPM. So for getting starting of a motor, when the motor starts, it provides me maximum starting torque. That means the torque is maximum while motor is getting started, and the torque and the rated torque is the normal torque what is it's working on. So as you can see, it is given that starting torque is equals to 175% of rated torque. That means this is equals to 1.75. So I could write ST is equals to 1.75 into RT, or I could write 1.75 is equals to ST by RT. Now what is this? Is ST is nothing but starting torque, and RT is the rated torque. What is their CS? That means 1.575 is your CS. So by substituting all the values over here, I could write M dash P is equals to 60 into 10 to the power 6 by pi 5 into CS. CS is nothing but my 1.75 into factor of safety is given 2, ZP is given 19, NP is given over here 3000 into CV is 3 by 8 into 600 divided by 3 is 200, 600 divided by 3 into 0.314. 1 by 3. Okay, so let me calculate this one. So it comes near about 99.59 or something like 6. Okay, 6 1 by 3. It will give near about your 4.636 m dash p. So we know that the module calculative designed module is 4 point. So we have to, as per design, I told you we have to calculate the maximum amount. That's what we have to approximate the maximum. So I'll approximate this one to 5. Okay, so I know the module design module for the pinion, that is nothing but your this one, pinion is 5. Okay, so I have let me do that. Now I know that MP is equals to 5. Okay, now going back to the formulas what we have learned in our previous class, that is nothing but module is equals to d by z. What is d? Is the diameter of pitch or pitch diameter, and z is the number of teeth. So m dash p is equals to dp by zp. Similarly, I could also write that m dash p is equals to since I could write m dash equals to z is equals to 5. Why can I write? Because it is mentioned in our question that these two gears are meshing. That means the module of this gear and this gear will be same. So m dash g is equals to dg by zg. Okay, now here it comes dp is equals to this multiplied this, and dg is equals to this multiplied with this. This 19 into 5, because we know that it's 19, we know it's 19, and we know it's 38. 19 into 5 and 38 into 5. It comes near about 95, and it comes out 190. Okay. Now our next part is to find the factor of safety. So it will help us to find out factor of safety, because now I got the module is should be 5. I got many more things, and I need to find out one more thing before concluding this part. I have to find out one. I have considered b by m is equals to 10, because as per the sigma ratio I have to consider this one. So what should be the module? What should be the thickness of the teeth? So how to calculate as per the sigma? I know b by m I have considered equals to 10. So I know MP is equals to MP m dash p. I could write in place of b by m. I could replace it by m dash p. That means b by m dash p is equals to 10. Therefore b is equals to 10 into 5 equals to 50 mm. Is also mm? It's also mm. So I have this one. Now I have to find out the factor of safety. What I know about the factor of safety, the basic formula, is working force or stress by maximum force by stress by applied force or stress, or applied maybe your allowable also. So in terms of gear, as I have told you in the previous class, the gear teeth is something like this one. So it will break in terms of cantilever beam. That means due to it will follow the cantilever theory. So that means it will break due to the bending. So what is happened? I could write SB is a bending force by the applied force. Here the applied force, as I have told you, P efficiency. Okay, fine. So I have to find out P efficiency and I have to find out SB. from which I could find out the factor of safety of my designed what I have done right now. So what is P efficiency? P efficiency is equals to CS by CV into PT. Do I know what is PT? No, I don't know. What is CV? I don't know right now, because you may tell me that we have find out CV over here. Where is the CV? CV over here. But the thing is that I have considered 5 meter per second, but I'll verify whether the velocity is 5 meter per second, or if I go for the maximum, how much maximum velocity I can get. According to that, I'll change it. So I have to verify it. I have to, and I only know this one. This is 1.75. Okay. Now, so what I can do? I could use the V, pitch line velocity. What is pitch line velocity? NP will be your, in terms RPM of the pinion. So let us put all the values. Pi into dp is 95 into 3000, 3000 into 6 to the power 3, 16 to 3 is equals to 14.92. That means the maximum V max can be taken as 14.92. So what should be the CV value then? CV value changes from, as we have, the CV value was less than 10, it was less than 10. So that's why I have considered 3, but now it's greater than 10. It's greater than 10. So I have to consider 6 by 6 plus V. That means it will come near about CV is equals to 6 by 6, 6 plus 14.92 is equals to 0.286. Okay, fine. I got it. I know what is CV. I know what is CS. I don't know what is PT. The most important part. I don't know what is PT. I know PT is equals to, again, 2mt by D, as I have studied in our previous class, is equals to D. Now in terms of pinion, it will be dP. Okay. So PT is equals to 2mt by 95. Now what is mt? Torque. So did I calculate the torque over here anywhere? No, I have not calculated. I'll use the simplest formula, 60 into 10 to the power 6 into kilowatt by 2 pi NP. Okay, let me calculate. 60 into 10. It will be near about 15909.308. 380. Okay, so therefore PT is equals to 2 into 15909.308 by 95. It comes near about your 334.934. Okay. Now I know PT. Therefore, the P efficiency, that means the effective efficiency, not P effective. This means P effective load is equals to 1.75 by 0.286 into 334.934 equals to, it is 1.75 into 334.934 divided by 0.286. It comes near about 2,946. P efficiency is equals to 2049.42. Okay, that is Newton. Now what is beam force? What is or the beam strength? I know B M B again mb sigma b into y. What is m? I know it's 5. From here I know that it's 5. From here I know it is 5. Okay, 5. What is b? B is 50. 50 into sigma b, it is provided over here, is 600. So how do I do? It's 600 divided by 3. And what is y? What is y? Y is 0.314. 0.314. It comes near about your 1507. Done. Now factor of safety is equals to, as I have told you over here, factor of safety is equals to SB by EF, because this is the maximum bending stress which it can blow. That is the maximum force you could actually consider, and this is the force you will be applied, P effective, the force you will be applying. Therefore SB by P effective is equals to 15700 by your, it comes number 334.9, 334.934. It's equals to, no, it's not 3, sorry, it will be 2, it's okay, 2049.42. that is 15700 by 2049.42 is equals to how much? 1570 divided by 0.49.42, 7.66, that is 8. So the factor of safety after designing is 8. Before designing it was considered to be 2, but I got it's 8, that is maximum. That means my design is safe. This complete thing has been done in terms of dynamic loading or bending, as dynamic loading, and in terms of bending stress. Now we'll consider about the hardness in the next part. Before that, hardness, we have to understand about few things, how the wear occurs in the gear. So in coming class, that is in tomorrow's class, we'll understand about wear, how the wear works, and how does the wear affects the gear system, and how from wear I could calculate the hardness of the gear, how much hardness gear should be, because gear goes through a frictions, and frictions has to be eradicated. So we'll learn about in the next class. Before that, we'll do some clarifications of your questions what I have received from the students. Okay, in this doubt clearing session, I will tell you some, I have got few doubts from students, I mean some queries. That is very good, they are studying. I need more questions. The first question was, what is PEF? That is here, what is PEF? Now, before to understand what is PEF, we have to go to understand something called what is effective loading. Now PEF is termed as effective loading. What is effective loading? The amount, or in other words, to make it very simple, it is the applied force. I will apply the force, not more than this one. This will be the force applied. This is the effective loading or effective load that would be applied to the gear. That is designed in so that this is the applied force will be provided in the gear, that is while meshing. Now there comes a question, is, as I have told you in the earlier class, that PT is equals to SB, because I could see that there is a one contradiction over here, that the PT over here is equals to PT is substituted as SB. Now there is a question comes, sir, this is right, I could take it as here in terms of this one it is right, but over here it is not the same, because it's not the same, because if I substitute over this over here, it's something there is some problem, as you have seen in your solving the question. So you could say that SB is not is equals to PT. Okay, so what is the main problem? The main problem is now the thing comes to be in clear part. The thing, what is the main problem is SB is equals to PT. It has been substituted in the first designing of designed in terms of beam strength. But when you are talking with effective loading, that means there's one more thing, addition thing, that is effective loading due to torque, because you could see that P efficiency is related to the PT and PT is related to the torque, that is the effective loading is completely dependent on the torque. So what you need to understand that in terms of effective loading, SB is not equals to PT. That means this PT is not equals to SB in terms of effective loading. Okay, but in terms of bending loading, SB is equals to PT. Okay, they are the same thing, but in terms of effective loading, there the SB is not equals to PT. It is somewhat related to PT with some factors like CS and CB. Okay, thank you students. You send your more queries. If you have more queries, you may contact me in my Google Classroom or contact me now in my phones. My phone numbers, if it is free for the study material is free for everyone. It's free for everyone. So share with your friends in your college as well as other colleges also, because it's a crisis time. So everyone need to get the knowledge without going college. So spread in your friends zone in the same college, in the other colleges also. Thank you. Have a nice day.
Me?